Next is vector space. For any vector x, vector y, vector z belongs to R3 and k, L belongs to real number, then if following property holds, then we can say set of R3 form a vector space. Then first property is if sum of two vectors, that is vector x plus y, is again equal to vector y plus x, that is if commutative law hold, then we can say first property is fulfilled to be a vector space. And next, if sum of two vectors added with third vector gives the same result as sum of a vector which is added with the sum of other two vectors gives the same result, then it is called associative law hold. That is, second property is fulfilled by the given vectors. So, number 3, if 0 is the identity element that should belongs to R3, then vector x plus identity element, that is 0 vector, give the same result, then fourth property is fulfilled and identity element is always unique. So a set to be a vector space, it should must consist an identity element in this set. So number 4 property, for vector x belongs to R3 and y belongs to R3 such that their sum is an identity element, that is 0, then vector y is the additive inverse of vector x and denoted by minus of vector x. That means if a vector belongs to R3 and is a vector space, then its additive inverse must be exist in that set. So number 5, k times sum of two vectors should also equal to k times vector x plus k times vector y. This should be equal to this result. Number 6 property, if two scalars are added and then multiplied with a vector will give the same result if individually these scalars are added to the vector and then their scalars are multiplied with the vector and then they are added, then these two results should be same. Now the 7th property, that is if two scalars are multiplied and then multiplied to a vector, it should be equal to a scalar should be multiplied with product of a vector with the scalar. This gives the same result. So property 8 is 1 into vector x, that is scalar is 1 and vector is x, should give the same vector. So if these properties are satisfied, then the vector set of vector is called vector space. So the set R cube with all properties is called vector space over R, and the elements of a vector space are called vectors. So this was all about the vector space. How can we say the set of given vector is a vector space? If that set consists identity element, additive inverse of each element and satisfies all these properties, then this set is called a vector space over the vector. Now the next topic is magnitude of a vector. That is, if vector x with component x1, x2, x3, then magnitude of x, that is denoted by modulus of vector x, is given by, that is modulus of vector x is equal to under root x1 square, x2 square, x3 square. For example, if we have vector x is equal to -1, 3, -4, then its magnitude will be, that is under root -1 square plus 3 square plus -4 square, and we get 1 plus 9 plus 16, that is under root 26. So that is the magnitude of a vector. Now we will discuss some properties of a vector of a magnitude modulus x. Properties of magnitude. So as is the sum of square quantity, so it will give the positive result because it is the magnitude. It gives us, if we have to find distance between two quantities, we can't say it is -10. Distance is always a positive quantity. So magnitude is always positive. So first property is mod x is always greater than or equal to 0. That is, if we have modulus x which is equal to sum of square of a quantity, then it will be greater than equal to 0. Now the second property is modulus x will be equal to 0 if and only if vector x is equal to 0, because as is the sum of the quantity, it can't be have a negative factor in the under roots. So there will be no cancellation of chances. So its sum should be a positive quantity, and this will be 0 if a vector is a 0. Now the third property is k times modulus of x is equal to modulus of k times x1, k times x2, k times x3 as a property of vector. So we will check out. It becomes under root k square x1 square, k square x2 square plus k square x3 square. That is, we get under root k square into x1 square plus x2 square plus x3 square. So that gives under root k square and under root x1 square plus x2 square plus x3 square. So under root k square can be written as modulus k square. So it gives and modulus x. So it gives modulus k. Sorry, here we can write it out. Modulus will be inside. Modulus k square. Modulus k whole square under root, because k square is a positive quantity. Modulus k square is also a positive quantity. So we can replace k square by modulus k square. So we get modulus k modulus x. So if we multiply k into modulus x, it gives the result modulus k positive value of k with modulus x. So this is the third property of magnitude of a vector. Now next one is unit vector. A vector x is said to be a unit vector if modulus of vector x is equal to 1, that is magnitude of vector x is 1. For example, if we have a vector x belongs to R square such that component of vector x are cos alpha, sin alpha, then its magnitude will be under root cos square alpha plus sin square alpha, that is under root 1. As modulus value is always positive, therefore magnitude of x is 1. As magnitude of x is 1, therefore vector x is a unit vector. So if the magnitude of any vector is 1, then it will represent a unit vector.